Good morning, everyone, and good afternoon as well if you're located outside of the UK in a different time zone. We'll just give it a minute or two for more people to join, and then we'll be kicking off. Okay, I think we can start. So thanks everyone for joining, and welcome to this webinar on charging infrastructure, regulations and certification of electric vehicles in India. So as I say, thanks very much for joining. We'll be with you for approximately an hour. My name's Bob Burgoyne. I'll be comparing the session, administering the Q&A, but really I'll be handing over as quickly as I possibly can to our two distinguished guests, so Manoj Desai and Debi Prasad from the ARAI and the Indian Energy Storage Alliance, respectively. I'll talk just very briefly for maybe 5 minutes or so about the catapults, what we're doing and what the overall Innovating for Clean Air programme is about. I know for some of you that will be old news as you're part of the programme, but we are also welcoming guests from lots of other organisations too. So I wanted to share a little bit with you about what we're doing and how this webinar fits into the broader programme. So just to talk a little bit about the catapults. So as you can read on the screen, Connected Places Catapults, we're an innovation agency. We support industry, we support places, academics, policymakers, across a range of sectors to do with the built environment, to do with connectivity, and electric and autonomous vehicles are a key part of our remit. So a lot of our programs are focused on moving forwards those industries, both in the UK and globally. We're part of a wider network of catapults, which is, I realise I'm kind of familiar with it now, but it's a fairly unusual name the first time you hear it. But there's a network of catapults across the UK, all focused on different areas, so ranging from medicines to semiconductors to offshore energy. For this programme, we're working with two other catapults, so energy systems and satellite applications. And the Innovating for Clean Air programme itself is focused on Bangalore in India, and it's funded by the UK government. It's a 2-year programme which has got another 4 or 5 months to run. What we're doing in Innovating for Clean Air, as you might imagine, is focusing on supporting to test, publicise and refine innovative approaches to improving air quality. And of course, supporting the transition to electric vehicles will have a transformative impact here, both on air quality and also on our net zero ambitions. So as I say, we're focusing in Bengaluru and India in the first instance for this project, and we've got a range of different partners we're working with. For example, the Indian Institute of Science have been a key partner for us, and we're also working very closely with the Directorate of Urban and Land Transport in Bangalore. So if any of you are based in India, you might have seen coverage at the weekend relating to the closure of Church Street in central Bangalore to motorised traffic. So that's a part of the programme, and the street will remain closed each weekend between now and February, and there'll be lots of opportunities for startups and innovators to demonstrate their electric micromobility solutions. So a lot of the kind of background policy and infrastructure information that we're talking about during the webinar today, we have partner organizations who are demonstrating their solutions on the ground in Bangalore at the moment. And there's a huge range of startups that we're working with. I'm sure quite a few of them will be on the webinar here today. So we're excited to be working with all of them. And the UK does see a huge opportunity in the Indian electric vehicle and infrastructure market. And the types of companies we're working with, quite a range of them across the whole ecosystem. So both from charge point suppliers to electric micromobility. We have, for example, on the call, Rerise, who are working on wireless charging solutions for buses. We have City EV, who, as you can see from the image on the left there, are working on they're rolling out a solution that converts lampposts to rapid charge points. So lots of other startups as well, and we're very grateful to our partners at Quanzin for bringing the experts together today to share their knowledge. And so I'm going to hand over very rapidly, and it gives me great pleasure to introduce Mr. Manoj Desai, first of all, the General Manager at the Automotive Research Association of India. So he's going to be talking about electric vehicle certification in India and the FAME schemes. For those of you who are not familiar, it stands for the Faster Adoption and Manufacturing of Electric and Hybrid Vehicles in India. So it's a very important government initiative on the Indian side to move forward the transition to electric vehicles. And then following that, we'll hand over to Debi Prasad Dash, who's the Executive Director at the India Energy Storage Alliance. And he's going to discuss the status of the charging infrastructure in India, as well as incentives and schemes to facilitate the rollout of more and better infrastructure. So we'll keep the presentations probably to around 30 to 40 minutes today, leaving plenty of time for discussion and Q&A. If you have questions that occur to you as we go through the slides, please type them into the questions box. And then at the end of the presentations, the panelists will address those questions. So again, thanks very much for joining, and thanks to our guests and speakers. I'll hand over now to Manoj, and thanks again for joining. Manoj, if you want to share your slides now.
Yes, so thanks, Bob. Good morning, everybody. So, Bob, can you see the presentation?
Yeah, that's perfect.
Yeah. Okay. So my name is Manoj Desai. I am from ARAI, India. ARAI is basically the premium organization for homologation and certification of the vehicles. And I basically work on electric and hybrid vehicles. So today, topic of my discussion is the same, like certification of electric vehicles and the components, as well as the FAME India scheme. So just a couple of words about my organization. So we established in 1966. We are at 3 locations in and around Pune, which is west part of the India. And we have almost all types of laboratories, right from the powertrain, exhaust emission, materials, electric mobility, safety and homologation, and NVH. So right for all the things required for complete vehicle homologation is available with us. And we have a new facility, that's Green Mobility Center. That's our electric vehicle certification facility. A little bit about regulatory mechanism in India. So basically, Ministry of Road Transport and Highways, which is responsible for all rules for certification of the vehicles in India. And ARAI has, which is having a responsibility of formulating automotive Indian standards along with the industry body stakeholders. So the MORTH basically, which notifies the standards, and then it becomes the mandatory requirement. A little bit of history. See, this 1999, the government decided to bring this type of new energy vehicles to bring under the central motor vehicle rules, and then the procedure for making the standards started. So in 2003, the committee, which is having test agency as well as the vehicle manufacturers, they published the standards, and 2005 onwards, it is a mandatory requirement in India to certify electric and hybrid vehicles. If you look at the vehicles which is currently available in India, so we have 2-wheelers, which is less than 250 watt. We have normal high-speed 2-wheelers. We have 3-wheelers. We have passenger car. We have electric buses, which are presently available, and there are manufacturers who are selling in Indian market. Now coming to the standardization, briefly, we have different sets of standards. So one is set of standards for electric vehicle. There is a set of standards for hybrid electric vehicle. There is a set of standards for retrofitment, like converting old vehicle. Then there is a set of standards which is for charging stations. And then there are certain rules for smaller power vehicles like two-wheelers and three-wheelers. If you broadly categorize the homologation procedure of a vehicle, so there are three areas where the testing is done. Like first is a verification, where functional and constructional checking is there, or there are certain lighting or windscreen wiping requirement. The other vertical is a safety, where electrical safety is there, water effect safety is there. There is a traction battery safety and the crash and EMC. And the last portion is a performance, where per kilometer, how much the vehicle goes, the energy consumption, motor power, gridability. So all performance parameters are there, which is also very important for qualifying for the incentive from the government India. So we will go one by one. So this is right hand side, you can see there is left hand side, it's a two-wheeler, which is a less than 250 watt. So it is similar on European line. So in this category, there is no homologation required. There is no registration required. So you can, the test agency has to verify few parameters and you can sell this vehicle in Indian market. And other side, you can see this is a three-wheeler, so which is a e-rickshaw and e-cart. So basically it is for last mile connectivity or first mile connectivity, and it is allowed on few roads. And there are few requirements that the speed must be less than 25 kmph and the power must be less than 2 kilowatt. In that case, there are few rules applicable in homologation, and you can sell these vehicles for last mile or first mile connectivity in Indian market. So other than these two categories which we discussed, these are the full set of standards used for complete homologation of vehicle, where registration is a mandatory. So we will see one by one. So first is AIS 38, which looks up to constructional functional safety requirement. So it is in line with ECE R100 standard. So basically mounting of traction batteries, ventilation, circuit breakage or crimped distance requirements are there. There are certain requirements for electric shock based on vehicle system voltage. There are requirements while you are connecting the vehicle to the mains network for charging. There has to be certain audible or visual indication. And there are very specific water effect tests considering the Indian condition, like garage washing or flooding or heavy rainstorm. So the idea is to check whether the isolation is maintained even after the water effects or not, for safety purpose. So these are certain tools, and the charger which is shown. So the chargers can be on board or off board. There has to be state of charge indicator or motor temperature indicator on the dashboard, so that that information can be conveyed to the user of the vehicle. Then there is a standard called AIS 039. That's the electrical energy consumption. So it is in line with ECR 101. And we measure here how much energy it takes for per kilometer. So basically the driving cycle is Indian driving cycle or modified Indian driving cycle based on the category of vehicle. And the next standard is AI 040, that is measurement of range. So how much kilometer the vehicle goes in one charge based on the stopping criteria defined by the vehicle manufacturer. So that is measured in this. Again, the driving cycle will be from Indian driving or modified Indian driving cycle. The next test is AIS 41, that is basically for motor power. So this test can be done at motor as a component. We have a motor dynamometers where all characterization can be done. And otherwise this test can be done on a chassis dynamometer, that is a motor power at wheels of the vehicle. And then there is a special mother standard covering all additional requirement for electric vehicle, that is AIS 49. So while conducting the brake test, what additional necessary things are there? When conducting the gridability, what should be the SOC? When conducting the electromagnetic compatibility, what are the requirements? So those are additional requirements for specific to electric or electric powertrain. It is given in AIS 49 standard. Coming to the battery, which is till today, it is certified as a component. So we have AIS 48 standard. So this specific standard was formulated in 2009. So that time in Europe, EC regulation R100 was not talking about the battery safety. So here in this standard, there are two types of electrical abuse and mechanical abuse testing. So this is the presently notified standard from the ministry, but we have already formulated two new standards. So one is AIS 38 revision 2, which is in line with global technical regulation GTR 20, and this is for M and N category vehicle. So here vehicle safety as well as traction battery safety at the system level is incorporated. So this, and the next standard is AIS 156, that is for L category, so 2 and 3 wheelers, and which is in line with R136. So here also vehicle as well as traction battery safety is incorporated. So these two standards are finalized. Now we are waiting for the notification from the ministry, and already some manufacturers who are utilizing high energy density cells, they have already started applying for the certification of traction battery as per the new requirement. Then there are a lot of old vehicles, gasoline or diesel vehicles, which are plying on Indian road. So there was a requirement from industry side. So we formulated 3 new standards, which is notified by the government. So you can convert the old vehicle with electric kit in hybrid or pure electric conversion. So almost all types of vehicles can be converted. So you need to do certain component level like battery, motor, controller, wiring harness, SOC indicators. So those components you need to test as a component level, and then you need to fit those components on target vehicle and do certain safety and performance testing on vehicle. And combining with this, we give a homologation certificate to the kit manufacturer who can start retrofitting the older vehicles on public road. Then there is a separate set of standard for hybrid electric vehicles. So AIS 102 Part 1 and Part 2, basically less than 3.5 ton and above 3.5 ton. So this standard takes care of all types of series, parallel, hybrid or mild or strong hybrid. So based on the architecture of the vehicle, we carry out the required tests, including exhaust emission, including electric range, if it is plug-in hybrid, or energy consumption, or traction battery application. Then there is another standard AIS 131. Any manufacturer who want to launch as a pilot activity or as a government project for demonstration any few number of vehicles, then instead of doing the complete certification, they can go with a small series way. So some of the tests from the vehicle manufacturers laboratories will be accepted, and only few vehicles based on the category of vehicles will be allowed to manufacture. So as a pilot activity, he can come into the market. Then for charging station, Ministry of Power has published the guidelines, and ARAI has established the laboratory, and we have started certifying public charging stations. So basically EMC, environmental, safety, functional testing, interoperability and backend communication will be tested. So in India, CCS and CHAdeMO is allowed, as well as we have Bharat AC and Bharat DC charging specification. So if anybody is interested to install charging stations in India, so they need to qualify IS 17017 series of standard, which is in line with IEC 61851 series. In addition to that, for onboard charges for the vehicle, we have recently updated our EMC regulation, which is in line with ECR 10.6. That is basically all the tests required for onboard chargers, such as conducted emission, conducted immunity, EFT, surge, so harmonics, flicker. So those are added. So we have all set of standards for onboard as well as external EVSE charging stations. Coming to the incentive scheme in India, it started in 2015. So the phase 1 for initially 4 years, and basically phase 1 was focusing 4 areas. One is demand generation, then supply related intervention, then R&D facility creation in India, and charging infrastructure. So this scheme initially was 2 years, but it got extended, and the 4 years this scheme was there. So getting the details and the feedback from the FAME 1, basically FAME 1 was having fixed incentive for different categories of vehicle, which was given to the vehicle manufacturer, and the manufacturer is supposed to pass it to the end user. Then in 2019, taking feedback from phase 1, the government launched phase 2 of FAME India scheme, which will be for 3 years, and almost 1.5 billion US dollar is reserved for this scheme. So basically it has 3 areas. One is a demand incentive, which is based on the battery capacity. There is a substantial amount kept for creating a charging infrastructure, and certain portion is kept for creating education or information for the college or regular users. Along with homologation, ARAI also does the eligibility assessment as per FAME 2 requirement. So this certificate is a mandatory requirement if you want to get the incentive from the government of India. So basically it has 4 steps. One is the initial assessment, where a localization, which is a mandatory requirement, certain components manufacturing has to be locally done. Then there has to be certain warranty on the battery as well as vehicle. Then there is a technical assessment where battery has to be an advanced battery, which is defined in the notification. Then certain features has to be there, such as the regenerative braking. The life cycle has to be defined. Then there are certain performance and efficiency assessment, like I discussed. The energy or range consumption parameters are decided for individual category of vehicles. So the vehicle manufacturer who want to qualify for FAME, he has to meet those requirements. And in addition, combining all this assessment, we issue a assessment report and a FAME certificate with which the government of India gives incentive to the vehicle manufacturer. So if you look at the difference between 2 schemes, the FAME 1 and FAME 2, FAME 1 was an older scheme. So here the focus in the both scheme was demand generation. The FAME 1 was based on the, it was a fixed incentive based on the category, but in FAME 2, the incentive is linked to the battery capacity which is installed on the vehicle. And the focus in FAME 2 is more on the localization. Like for electric buses also, FAME 1, the capex amount was given to the state transport authorities to purchase the buses, but now the FAME 2, it is a OPEX model. There will be funding, and the charging infrastructure is identified in both the scheme. So as a part of FAME India 1 scheme, ARAI also has, my organization has also established a center of excellence. So we have almost all types of facilities. We have facilities for motor testing. We have facilities for simulation or integration kind of or component sizing. We have facilities for structural dynamics. We have facilities for lithium-ion battery testing, right from cell level, module level, pack level. We have facilities for material analysis of the cell, and facilities for charging stations, EMC, as well as CAE. So we have all sets of facilities in our center of excellence, and we help industry for homologation as well as certain design activities. So this is all about the ARAI as well as the Indian homologation mechanism for electric vehicles and the components. Thank you.
Thanks so much, Manoj. That was really, really fascinating. So we've got a couple of questions coming in, but I think we'll hand over now to our next speaker, to Debi Prasad, and we'll take the questions at the end. So Debi Prasad, if you want to share your slides, please.
Yes, sure. Hi everyone, greetings from IESA and India on charging infrastructure. I'll be happy to speak about EV market and EV batteries and charging infrastructure. And thanks to Manoj ji mentioning about all the certification processes and ARAI's role. And ARAI is one of the key player in the Indian charging infrastructure and EV space, and they are driving the market. And I hope everyone able to hear me. And we closely work with ARAI and Manoj and their team. And we at IESA work with more than 107 companies as part of IESA in Indian energy storage and EV market. And just giving you some glimpse across the globe, the EV cells. If you have heard today's news, Tesla's fast charger has been crossed 2000 Yes, 200,000 installations in US, and we see it can grow in US and across the globe. And we see this market will go forward, and sales of electric cars across the globe has reached 2.1 million last year. This year we don't have an updated number, but we expect it will double this year. And there are over 500,000 e-buses, almost 4,000 vans and trucks. So across the globe, China is leading the market. We expect both plug-in electric vehicle and also battery electric vehicle. Both will go parallelly, and there is also a scope for hybrid vehicles. The companies like Toyota and others are working in that space. On comparing to different countries, US, Germany, Norway, China, Japan, they are leading the space, and Finland also doing good, and UK is also driving the market. So these are the leading countries who have suitable policies, both for electric vehicle charging infrastructure, also for the electricity tariff for the charging infrastructure. When considering Indian market, the market has started from 2006, but from 2013 there is an actively policy has been taken care of by both central government and state government. Different policies has been formed, few implementation agencies including BEE, ESL and others, including ARAI, ICAT, they have been testing and taking active role in this space. So there are different policies has come up over the years, which includes FAME policy, NEMMP, FAME policy. Recently, last 2 years back, there was a policy in Western transformative mobility and battery storage, which includes on the manufacturing side. Recently, BEE is also planning for the star rating for electric vehicles. BEE has been notified as a central nodal agency for charging infrastructure. And recently swapping is also accepted by the Ministry of Road and Transport as another business model. So different suitable policies has been launched or has been announced by both central and state government. Recently Delhi and Telangana government has also floated few policies. Just considering the different vehicle types in India, it may be electric two-wheeler, three-wheeler, which is a unique market in India, three-wheelers. And that is also rapidly growing. And electric four-wheelers, there are few limited players in India. And also beyond four-wheelers, there are passengers and goods carriers are there. There are electric buses are there. Considering as IESA, we evaluate the market every year. So what we feel that there is around 3.8 lakh, which is around sales of EVs happened in 2019 to 2020, which is you can consider is moderate, and we expect most of the sales has from electric two-wheeler and low-speed three-wheelers, but there is significant sales also happened in high-speed three-wheelers and electric four-wheelers and electric buses. That create a demand of 5.4 gigawatt hour of batteries for these EVs in last year, which is 2019 to 2020. And measure of these batteries are from lead acid, and few of them are from lithium-ion space. And if you consider the battery market, we expect there is a significant change is happening. The companies have started installing lithium-ion batteries, and we expect there is a growth of 36% cumulative sales over the years expected in next 5 to 6 years. And currently 75% of EV batteries from two-wheelers and three-wheelers, as I mentioned, is from lead acid, but that shift is happening. And for that, as I mentioned, there is a policy which is central government is in discussion on manufacturing side. And if you compare the different states, apart from the recent states announced, Telangana, they are one of the best states for the manufacturing. As per the policies, we'll have to still wait for the implementation side, but different states have floated their policies, maybe the full policy or the draft policy for the EV and ESS adoptions. Delhi is also giving incentive on the scrappage, like if you have an old EV or if you have an old IC vehicle and you want to buy EV vehicle, there is incentives. If you want to replace your batteries in EV after fast use, for secondary batteries, second life of batteries, and for recycling. So Delhi is also have a good policy. Similarly, Telangana also have policy. Before that, the first policy came up by Karnataka 4 years back, and other states have also some policies in the space of EV. and they are giving incentives on tax side, also on the they're giving incentive on manufacturing of EV batteries or electric vehicle at a location. And India also accepts most of the charging standards, have also unique charging standards on Bharat charging standards, which is co-developed by ARAI and other bodies. On an EV charging tariff wise, it is not too high compared to global market. It is limited to 5 to 7 rupees in India, which is you can consider around 10 to 12 cents. And in that ground, different states have different tariff structure or electricity charges for the electric vehicle charging, and they are working on that. So it may change over the years because it is at nascent stage and states are evaluating how they can have a business model, or utilities are evaluating how they can have a business model in this space. And also few states we are expecting how they are coming up with different policies for the giving incentive to the charging infrastructure developers, or maybe swapping system installer developers, but it is at good stage compared to other industries in past. As already mentioned by Manoj Desai, I don't want to take much time, but the FAME policy we're expecting till next 2 years, and it will drive the major market for EV charging infrastructure, having a 10,000 crores of rupees for the incentives. So this is one of the good policies which were 1,000 crore out of that is only for charging infrastructure, and 9,000 is for the electric vehicle. So we expect it will definitely drive the market. And if you think about who are the major players in this space in the charging infrastructure, there are different type of chargers like low power EV charger or medium power EV or medium power EV charger on Bharat EV standard. So players includes Delta, Mastec. Delta is a global player. Mastec, Magneta, Exicom, they are Indian players. There are global players like ABB, and they are also actively in the active in the market. There are a few companies like Triton and others, or Photom. They are also trying to enter Indian market. So already there are more than 30 plus players are active in the charging infrastructure space in India. And so what we expect over the years, there is a demand of around 1.4 gigawatt of electricity demand only for the charger load, which we can say this is maybe the peak time demand for the charging stations in next 5 years. India might expect out of all type of vehicles. And with FAME 2 incentives, the electric buses are also increasingly adopted by different STUs, state transport authorities, and also private players. And what we expect also in the revenue forecast, we expect BAU scenarios like to may go from 400 to 1400 crores as a market revenue from this case. IESA closely work with both state and central government bodies, including we closely work with Maharashtra, Karnataka, Delhi. In past, we did state level roundtables under MOVE initiatives of IESA, and we closely work with global startups in this space. You might have heard about few global startups, which is on the Arthur Energy, one of the leading two-wheeler players in India. We have also few other players from the batteries and charging infrastructure space. And we closely work with government, including Mighty Startup Hub, Startup India, Invest India, and we try to help them to install the projects also in the investments, and also having the technology partnership with other global players. We also closely work with few of the EV fleet operators, which includes Blue Smart, Triple Taxi, and others. They are the dedicated EV fleet operators in India. We try to monitor the EV pattern and the battery health in these EVs. And this is in pilot project. And if anyone interested, we'll be happy to work with them in this space. And this is by government, but we expect how they are planning to do an integrated system, including from payment application to charging infrastructure, also on the billing side. They have also planned to expand this to V2E concept, like vehicle to grid, or V2G concept, like how vehicles can charge to the discharge the energy to the grid, so to balance the requirement of grid, or it can be used for the grid stability. So this concept is proposed. We expect that after few IFCAs in India, maybe in next 2 to 3 years, it will see the reality. And if you just giving an example of how Indian electric buses have different battery sizes, like giving you scenarios of battery capacities of different, like if you have a overnight slow charging, then your battery size may be lower size. And if you have a fast intermediate charging, then it can be lower, it can be much lower than that. Then if you have a electric trolley buses, then you can have smaller batteries. So how the battery size depends upon your charging patterns. Like if you have a overnight charging, you have a long time to charge and you can have to charge once, so the battery size is higher. So based on the requirement or based on the applications, how battery size for electric buses can be different in India. So this is giving one example, like if you have a 6-meter buses, India mostly use 60 to 140 kilowatt hour batteries. Similarly, for 8-meter buses and 10 to 12-meter buses, the battery sizes are different. This is the recent MOP guidelines on public charging stations in India. So they have floated guidelines for installation of charging stations in India, and this actually drives the adoption of both CCS and CHAdeMO certified chargers in India. And these are the active players which I already mentioned in the charging solution space. All of them are not charging infrastructure provider. Few of them provide the solutions. Few of the companies just install the charging stations. Few of the companies are the assemblers of the components. So it's a combined, which includes a few companies from swapping space also. We do various activities in the space of electric mobility with the support of ARAI and other stakeholders. We did a dedicated event called India Mobility Conclave every year. We do a swapping roundtable. We did also a roundtable on the electric vehicles, batteries for electric vehicles, and we did a webinar on the fuel cell vehicles. And if you consider the battery swapping scenario, it's at very nascent stage, but with few more policy modifications in last 4 to 6 months and active involvement with BEEE and others, now the market is stepping up and government started recognizing it as another business model. In that space, like EXICOM, Sun Mobility, Bounce and others have started working in this space. And we expect like it is not like a win, who will win, it is swapping or charging infra. We expect both the cases will be there in India. There will be limited applications of swapping will still exist at different controlled environment. So both will be there at different business case will evolve over time. And we ISA create a report, annual market overview report. Some facts I have shown in the last slide. So this year report is already released, and if you're interested, let us know. And we have different initiatives on the space of batteries, on alternative batteries like aluminum air or maybe any other chemistries. We work on that space. We have a recycling initiative. We work in the microgrid storage on training. So we work in across space of both energy storage and electric mobility. And one of our proud member is also hosting the webinar, like OneChain is also there. So we closely work with more than 106 companies, and we'll be happy to facilitate any companies entrance to India or any specific market queries. We'll be happy to address on that. And IESA, India Energy Storage Alliance, is operated by Customized Energy Solution. It's a global energy solutions firm based out of US, having 7 offices across the globe since 1998. Thanks everyone. If anyone have any queries on the market side or on business side, I will be happy to address.
Debi, Prasad, thank you so much. That was a really comprehensive presentation. So thanks again to both of our speakers. So Manoj, Debi, Prasad. Had a few questions come through. I'll ask them in no particular order. And I should say, actually, before I jump into the questions, that our speakers have kindly agreed that we can share their slides afterwards. You may have noticed there was a lot of information on the slides, and if you were there trying to take screenshots rapidly, then don't worry, we will be able to share the slides afterwards. So the first question, I'll ask a couple of quite specific questions on homologation, and then sort of jump into some more general ones. So there was a question on the requirements for sort of minimum data to be sent from charge points to allow the government or the authorities to keep track of usage of charge points. So are there any standards regarding the kind of the data that the charge points capture and then send back for analysis? I guess that's a question mainly for Manoj.
Yeah. So as of now, there is no such mandatory requirement for backend communication or sending data to the government. Of course, there are industry who are working on OCPP or other standard, but it's not a mandatory right now sending back to the government.
Okay, so that's pretty clear. And what are the standards related to the kind of electrical and the earthing side of the charge points?
Yeah, there is a notification from Central Electric Authority in India, and they have given all safety standard. So there is a standard called IS 732, which is for earthing requirement.
IS 732.
Yeah, that's the Indian standard, IS 732.
Okay, and are these the standards you're referring to? Are they published online? Would they be easy to access, or?
IS, you need to go to Bureau of Indian Standard website and need to purchase. All IS standard you need to get it from BIS, Bureau of Indian Standards.
Okay, and you have to.
Yeah, but AIS standards, Automotive Indian Standard, those are published on ARAI website, and it's freely you can download it.
Okay, that's good to know. I had a question, actually, a more general question around standards. So, are the standards that you're describing, are they unique to India, or are there some standards which are also reflective of international standards or standards from another country?
Yes, most of the vehicle level or component standards, they are in line with ECE regulation, and we are party to 1998 agreement, and so we will be following GTR, Global Technical Regulation. As and when there is a development happens. We are also part of electric vehicle safety group. So we are tracking what is happening at international level, and we'll try to follow those. And EVSE, the charging station standard, are also in line with IEC 61851 series. So you can say it's more or less in line with international requirement. Only few additional specific to India requirements are there. So like environmental condition or water effects are there. Mostly you can say 80 to 90% it is in line with ECE regulations.
Okay, that's helpful. Is it easy to find out, you know, the India specific requirements, or,
yes,
or would someone, it is easy to find? Okay, that's good to know. And regarding homologation process, how long would that typically take, and how much would that normally cost to go through that process?
Okay, so basically vehicle homologation has, you can say broadly, there are two parts you can say. One is the component testing or component certification. Components such as right from your tire, wheel rim, reflectors, mirror, headlamp, tail lamp, and all those components, as well as electric motor or batteries. If those are certified, then it is directly you can go to the vehicle level certification. So vehicle level certification, typically it will take 6 to 8 weeks time, completing all tests, which involves roadworthiness trial, which involves laboratory performance testing, which involves safety testing, including EMC, and certain installation requirement. So mostly our suggestion to the vehicle manufacturer is either start with component approval or choose the components which is already approved as per AIS requirement. For example, if it is a mirror or tire or wheel rim or reflector, which might be available in common market. If it is a very specific design unique to your vehicle, then you start with component and then go for a vehicle approval.
Okay.
Cost, I think we need a vehicle specification. Based on that, we can tell you what are the charges required for the homologation. Okay,
and so I mean, just ballpark, is that, you know, $1,000?
I will just for if it is a two-wheeler, say L1 and L2 category, it will be something around INR, Indian rupees, 15 to 16 lakhs. It's only vehicle level costing, not the component. But definitely, if it is a passenger car, then there are many regulations like crash testing, and all these are also mandatory. So bus and electric car, it will be more because there are more tests on component as well as vehicle level from safety point of view.
Okay, yeah, that's really helpful. Okay, that's good. So we had a question which I know you answered partially in the Q&A chat regarding wireless charging. So you mentioned that wireless charging, there's no standards established for it yet. Do you know, is there any are there any standards being developed, or is there any policy being developed regarding wireless charging? Maybe Debi Prasad, you might have a view as well.
Yeah, I think Debi, you can add, or we are part of the standard committee also, we can add. Yeah.
You can start, then I can add on it.
Yeah, see, the idea was initially to focus on conductive charging and prepare the standards necessary for those EVSE first. So those are now prepared, those are published now, and most of the manufacturer has started certifying the charging stations. The wireless charging will come in later stage, maybe another 1 year's time. The committee will start working on those. So before that also, there are certain plans to make some additional standards for smaller charging station or battery swappable things. If that work is done, then the next area will be wireless charging.
So I think it may take another 2 to 3 years minimum to start working on the wireless charging, as the demand side is also very low, and maybe a few lab scale pilots are going on in wireless charging space, may not be on wide uses in India. So it may take some time.
Just to add one more thing, but it will not restrict anybody if coming with that concept, because if any vehicle manufacturer is coming with that concept, he can be homologated, he can launch with the present available safety requirements. So it will not be a restrictive kind of thing.
Okay, so yeah. So you just have to comply with the other relevant standards, and it should be still possible. Okay. We had a couple of questions, and I think Debi, you touched on this already, about and you talked about the vehicle to grid, opportunities. So how much sort of validation or testing or planning has been done from the different grid authorities to prepare for the transition? Because as you said, the market is growing so rapidly. It's maybe doubling in size year on year. There will be a very big impact on the grid. So how much preparation is happening on that?
So actually, based on the study by CEA, they are telling that up to 30 gigawatt of additional EV load, the current grid is capable to add that. But what we expect, it is not about the total EV load, it is about the peak load. If all EVs will come at some point of charging at the peak time of evening and morning in India, it will definitely impact the grid, and it will impact the grid frequency. So B2G is one of the concept, but that is not the only concept. There is like, if you do the demand side management, there are few pilot projects by utilities already started on the demand side management pilots, or there is incentive of TOR, like time of the day charging tariff for the electric vehicles. Like in peak time, there will be high charge for the charging of the EVs, and off peak time it will be, so that vehicle can manage the grid also the way. So, and there are few pilots on the battery storage for the substation level is also planned by the utilities. So these 4 to 5 solutions will definitely address the issues of the grid load from these EVs. So it may not be immediate issues, but the utilities and CRC and CA, the regulators on the electricity grid side, is aware of it, and they are taking consultations from the private parties and also from the state nodal agencies to address this issue in future. Okay,
and I saw from your slides, looking at the different policies and incentives across the states, that there's quite a lot of variation. So some states are really progressive and very active in this space, and other states are less active. So a question sort of on behalf of the international companies on the call, what would your recommendation be with regard to market entry in India, given that there's this very big difference across the states? Would you say focus on 1 or 2 states, or is there what are the kind of considerations for market entry given that variability?
So it's not be based on the state incentive. That is only the one part of the game. It should be like how the EV adoptions or the demand side. If a state is giving high incentive, but there is no demand as a whole, if you are a vehicle manufacturer or your charger for the two-wheelers, four-wheelers, or maybe electric buses, you will think about which states have a high demand. Just giving a fleet operators example. Fleet operators may not go to the states in the northeast of India. They will definitely go to the metro cities and the operations like maybe lithium cab or Ola or Uber, because they are also now started accepting electric four-wheelers as the fleet as part of the fleets. If your charging stations are targeting to the fleets, you should not think about the incentives. You should think about where is the demand of your charging stations. And also the land cost. It is the cost of electricity is not the only cost. You have to also consider the land cost where you are installing your charging stations. There are other cost of the operation and maintenance, and also the cost of the network. If you have 10 or 15 charging stations, how you can interconnect themselves. So there are many other parts, and how grid is connected to your charging stations. Like giving an example, there was a proposed charging station supposed to be installed nearby Delhi airport. Without mentioning their name, it is for a two pilot electric buses. But the cost of distribution line from the nearby substation to the charging station installer point was too high. So that was not a feasible solution. So you should also consider how far your nearest substation is there from your charging points. So there are many other parameters you should consider apart from the tariff, and that can be changed anytime by the states. And as the market is nascent, these are the indications. So over the time, it will definitely may not have a huge difference between the states.
Yeah, that makes sense. So yeah, it's look at probably the demand is going to be more a more kind of solid foundation upon which to base your strategy rather than the incentives which are transitory potentially. Yeah, that makes sense. Okay, so I had a question as well here about the four-wheeler market. So you mentioned that the four-wheeler market, and you showed some stats. It's currently very, very small for EVs, but you're also talking there about fleet operators, about lithium and other players who are entering the market with four-wheelers. Is that the main opportunity you see for the four-wheelers, or is it likely to be driven by fleet operators rather than private ownership?
Okay, I can add some points, and Manoj can also add few points to that. So four-wheeler market, the product limitations are there. In India, less than 10 products are available in electric four-wheelers. So their consumer have a limited choice. So that's the first thing. So you should not think about, if you're planning to launch a four-wheeler, you should launch now. And second part is that who will adopt your four-wheelers? One is fleet operators. Definitely, they are the one of the aggressive player at current market. But the second is like corporate offices. Sometimes these fleet operators serve to large IT companies, large manufacturing companies like Cisco, Philips, and others. But they are also now buying their own fleet because they have a transport departments or large universities or industries built like Mahindra, Tata. They are also now planning to buy these four-wheelers for their employee transport. So that is the second chunk. And third is regulated market, like ESL is bulk buying for the government employees or from the PSUs, public sector companies. So that may be the third group of target. Fourth group of target may be the Indian HNIs who want, those are focusing on the air quality in this duration. Like now Delhi is also, with lockdown also now air quality is not good. So there are few HNIs, those focus on good EV products, and they also focus on air quality, and they also concern about the pollutions. So you think about these HNIs. But my first point was that product is limited. So you cannot consider the current growth of four-wheelers. Maybe the growth rate will remain same for next 5 to 10 years. With more new products in the market, the market may grow exponentially. But these are the 4 or 5 segments where companies should focus.
Yeah, that makes sense. Certainly in the first instance. Manoj, did you have a view on that as well?
Yeah. Like Debi rightly said, now it is even there are fleet owners who are using four-wheelers, as well as individual users has also started purchase, because there are 2-3 models in SUV section which are quite attractive and people have started. Another reason is in case of phase one, 2015 to 19, For personal use or private use also incentive was there. But in phase 2, the government has specifically kept incentive for a commercial application like fleet owners only. And that too, there is a upper cap on the cost of the vehicle. So not premium vehicles. In case of premium vehicles, the incentive will not be given. There is a cap, upper cap is there. But I think it's growing because there are few companies, basically MNCs are there, or premium car vehicle manufacturers. So they are launching electric vehicles in India. And there was a rule which the Ministry of Road Transport published. It's a gazette notification which allows 2,500 number of vehicles without certification in India. You can bring it without homologation, provided you must have ECE, EEC or Japanese approval. So if the country of origin where the vehicle is homologated as per ECE, EEC or Japanese, you can bring those limited numbers in a year. So certain premium vehicle car manufacturers, they are taking benefit of that and they are launching models. So the picture will change.
Okay, that's really.
Hi, it's Lovedeep here as well. Manoj, just another point on this one is this four-wheeler market, is it also limited by charging infrastructure as well, compared to especially?
Yeah, you can say, but I think most of these owners, they are installing chargers at their home or offices because the distance covered is quite short. I think Debi ji may add more thing. I don't think so.
And this is a combined, like if you are buying a Mahindra E2O, they are also facilitating the charging infrastructure installations or charging station installations in your parking lobby. So we cannot blame charging infrastructure. If you blame, then market will not come any day. So yes, we can consider maybe 10% as a constraint, but it is not the constraint for the growth of the EV four-wheelers.
Okay, thank you.
That's great. Okay, so we're approaching the end of our session. I've just got one very basic question, I think, for Manoj regarding the kind of certification. So you mentioned, I think, a center of excellence and testing, a facility to go through the certification processes. Where is that, or are there multiple centers in India which manufacturers can use for the certification process and the testing process?
So our COE is at one location only in Pune. But if you see for homologation, there are two, other than ARAI, there is another center also where the manufacturer go for the homologation. But COE as such for component which is more on development side or while designing, so which only we have right now, which is in Pune. Yeah.
Okay. That's great. So we're running towards the end of the time. So I think it remains only for me to say thank you very much to Debi and Manoj for a really fascinating presentation and really insightful Q&A as well. I think I personally learned a huge amount in the last 45 minutes, and I'm sure everyone else did as well. So thank you, a huge thanks to both of you. To everyone who's attended, thanks very much for joining. We'll circulate the slides, as I said, afterwards. We do have further events coming up, so Connected Places Catapult